This is my last video of 3 on simplifying radicals. Each one of these examples are going to be dealing with quotients. And again, here I have my list of perfect square roots that will come in handy when we go to simplify even farther, and then a reminder of when we have even exponents on our variables, then we can just take half of that exponent and that will make it a perfect square. Alright, so a lot of different things that you can do when you have quotients inside here. First of all, I'm going to take a look at what's underneath there. I have square root of 11 over 49, one great big radical. Alright, now if one or both of these are like perfect squares, then I'm going to want to break this great big radical up into two small ones. And as I can look, 49, square root of 49 is 7, so it is on there. So that's what I'm going to want to do. I'm going to want to make it a little square root over the top and a little square root over the bottom. Okay, that is a legal move that we can do with radicals. All right, square root of 11, I can't simplify, but that square root of 49, I can simplify. So this would become square root of 11 over 7, and then I'm done. I don't have to do any more with that. Okay, again, taking a look at this second example, I'm going to take a look at that quotient inside that radical, and I'm going to see what I can do with it. All right, square root of 25 is a perfect square, and because this is x to the fourth, that's an even exponent, then it definitely is also a perfect square root. So I'm going to take the one great big radical and I'm going to break it up into two small ones. So I can take the square root of 25 on the top, I can take the square root of x to the fourth on the bottom. Square root of 25 gives me a 5, square root of x to the fourth gives me an x squared. So again, relatively straightforward there. Okay, now over here on this one, let's say I want to go to this example over here. Let's say we're taking the square root of 88 over 11. Alright, well, square root of 88 is not a perfect square, so on our list, square root of 11 is not. Alright, however, if I continue to take a look at what is going on with these two numbers in here, I can take 88, divide by 11, and that turns out to be 8. So if I can divide them, I can do that. So 88 divided by 11 is 8. That's going to simplify this down into the square root of 8. Now, I cannot just assume that I'm done at that point. I do have to make sure and see if I can simplify. I can. 4 goes into 8. 4 times 2 is 8. So then I can go back to the factor tree that I had in the first two videos. I can break this up into the square root of 4 times the square root of 2. Square root of 4 is 2. Square root of 2 is 2. So 2 square root of 2. Alright, now sometimes it'll work out like that, sometimes it won't. Coming over here to this last quotient right here, alright, well, I can't go 12 divided by 27 like I did up here. That didn't work. Alright, however, if I just examine 12 over 27 and pretend like it's a fraction, I could reduce that fraction to lowest terms. And then, recalling laws of exponents from a few chapters ago, x to the third over an x, alright, I can do laws of exponents. I can subtract those exponents and get an x to the second. So that's what I think I'm going to do. I'm going to take 12 over 27, and I'm going to reduce it to lowest terms. I'm going to divide the top by 3. I'm going to divide the bottom by 3. That's going to give me a 4 and a 9. So 12 27ths reduces to 4 ninths. Now I'm going to deal with those variables. X to the third divided by an x to the first. The rule says when dividing like bases, we subtract the exponents. There's a little imaginary 1 right there. That would give me an x to the second in the top. Alright, now the radical is still there because all I did was just manipulate underneath that radical. Alright, so I've reduced to lowest terms. Now what that has gotten me, now I have 4 and 9, both of those are perfect squares. I have an x to the second, again another perfect square. So now I'm going to break it up into two little radicals, radical on top, 4x squared, and radical 9 on the bottom, both being perfect squares. I can do the top as 3x. Oops, sorry. I can do the top as 2x and the bottom as 3. Alright, so 4 little examples there of showing how you can deal with your quotients. Hopefully, maybe they'll divide out evenly. If not, you can maybe reduce them down to lowest terms and they might become perfect squares for you, or you can immediately break them up because you were given perfect squares underneath that radical to start with. Alright, so 4 examples, last video there of simplifying radicals.